Hello, 7th grade. This is lesson 18. Our objective is how do you name and classify polygons? So first of all, let's talk about what a polygon is. When you have three or more line segments that are joined end to end or together to enclose a portion of a plane, a polygon is formed. So I've underlined some important things. Line segments have to be straight pieces of line that are connected together at their ends. And then they enclose, so it has to close something, a portion of a plane. That means it has to be like on a flat surface. It can't be a three-dimensional figure. And then if all those things are met, then we call that a polygon. So on the left here, there's some examples of a polygon. Over here, straight edges, not crossing over. These over here are not polygons. This doesn't have a straight edge, so nope. This one has a couple straight edges, however, that one side is curved, so again, not a polygon. This is a cube, so that's not a polygon. This looks like it is, and notice there's a star over here, but this one's not because those sides cross over each other, so it's not a polygon. And then this one, notice it's not closed. It doesn't, if there's another side here, then it would be, but since it's open like that, then it's not a polygon. So to name polygons, we simply name them by the number of sides. So if there's 3 sides, we call it a triangle. If there's 4 sides, we call it a quadrilateral, prefix of 4. 5 sides, a pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. 11 sides, undecagon. 12 sides, dodecagon. And then if it has more than 12 sides, then we call it an n-gon. So like if it had 15 sides, we'd say an 15-gon. Now to name them, like if you're going to describe them like on a page, then we name them by the vertices. So we just kind of go in an order. So notice there's 8 different ways to name this one. So you could say USTV, quadrilateral USTV. Or if you wanted to, you could start at the S, STVU, right? So just kind of going in order. But you could also name them counterclockwise if you wanted to, like UVTS or TSUV. Any of those would all talk about the same shape. Now, there's a special kinds of polygons that we call regular. And they're regular polygons whenever all of the sides of the polygon have the same length and all of the angles have the same angle measure. So for like a triangle, this is a regular one because all 3 side lengths are the same and all 3 angles are the same. This is an irregular one. Notice this angle is smaller than those. This length is shorter than those. Quadrilateral, that's when all 4 sides are the same length. All 4 angles are the same. This is a quadrilateral that's not regular. So kind of just give you an idea of what a regular one looks like compared to irregular. So now when we're comparing different shapes, something that we call similar. And similar figures have the same shape. And they may or may not be the same size. So over here, notice this 1, 2, and 3 are all similar, but this 4th one is not, because even though it's a triangle, it's not the same shape, right? Those angles are different. And then if a shape is similar and the same size, then we say it's congruent. So over here, triangle ABC is similar to triangle DEF, but it's also, even more specifically, congruent. So ABC is congruent to DEF because they're the same size and the same shape. Notice if you flip it like this, or if you turned that, it would still be similar. Okay? So it would still be congruent. That doesn't affect it. Now, this shape, I would say, is similar to these, right? Because it looks to be the same shape. However, I cannot say it's congruent, because congruent is same shape and the same size. Now, corresponding parts is kind of like the pieces that are in the same place. So angle C corresponds to angle F. See, those are both like that small angle in there. You could say angle B corresponds to angle E. Angle A corresponds to angle D. Okay, so it's kind of just what is in the same position in that shape. Now, here it says, which of these quadrilaterals appear to be similar? So you don't have to measure it or anything like that, but just ones appear to be. So remember, similar means same shape, not necessarily same size. So this is like a rectangle, rectangle, and rectangle, where the height is about proportional to the length. So I'm going to say 1, 2, and 4. For part B, it says which ones appear to be congruent. So that means now they have to be both the same shape and the same size. Congruent, I would say this one and this one look to be the same size. So they have to already be similar in order to be congruent. So I'm going to say 1 and 4 appear to be congruent. Alright, what shape is a stop sign? Well, if you remember, a stop sign looks something like this. It's a really horrible one, but you get the idea. Stop making fun of me. So that is 8 sides, so that's an octagon. An octagon. What do we usually call a regular quadrilateral? Remember, quadrilateral means 4 sides. Regular means that all 4 side lengths are the same and all 4 angles are the same. So what do we normally call a quadrilateral with 4 congruent sides and 4 right angles? We'll call that a square. What kind of angle is in each of a regular triangle? So what kind of angle? Regular means all 3 side lengths are the same and all 3 angles are the same. Notice all 3 of those are going to be acute angles. It's an acute angle. D. Are all squares similar? How do you know? Well, are all squares? Remember, squares have 4 congruent sides and 4 angles. So then are they all similar? I would say yes. How do we know? Because they are all the same shape. Are all squares congruent? I would say no. They're not, because some of them are bigger than others, right? Congruent have to be the same shape and same size. So F, now coming to F, says sketch a pentagon. Remember, a pentagon has 5 sides. So 1, 2, 3, 4, 5. Hexagon, that has 6 sides. 1, 2, 3, 4, 5, 6. We're just make sure you're using straight edges there. Now, could we have done different ones? Yes, we could have, but that's just the one I'm doing. And then a heptagon. Heptagon has 7 sides, so 1, 2, 3, 4, 5, 6. Maybe we should have that last one shorter. 6, 7. There you go. Your homework, if you haven't seen it already, starts on page 125. You can do all of them from lesson 18 and from lesson 17, and then 14 more of your choice.